IPsec, we started talking about Ike Key. And in Ike Key, we talked about the two major components, اللي هو the mechanism, okay? And these are the features of the mechanism, including how to deal with clogging or denial of service attack, how to do a key exchange using Diffie-Hellman. We talked about the Diffie-Hellman group. We said that each group has a certain security level, and nonces using replay attack. By the way, here we have nonces for replay attack. Didn't we say that we in IPsec we use anti-replay window?
Yes.
Right. So why do we use nonces here? So this is also to mitigate replay attack. Why do we talk about nonces here as replay attack, where we talked about anti-replay window for IPsec? Because this is for
Key exchange.
for key exchange, for Ike Key. This is for the traffic inside Ike Key, which, as we said in the original architecture, if you remember, Ike Key uses a separate stream. In fact, we'll talk about two different streams for Ike Key to establish the security association. We'll talk about two different streams. One to do key exchange and one to do some control messages that are needed. تمام. And we talked about طبعا اللي هو الايه authentication. كويس والله. Be recorded. Okay, I think that's good. Okay. طيب بسم الله الرحمن الرحيم. Feature. So now these are the messages. So the messages. This is the header. This is the header for Ike Key. This is different from ESP, AH. This is different, totally different. But there is a very important thing to notice here is that you have this is the whether we do host to host or firewall to firewall or router to router, we have two different streams for Ike Key, two different traffic for Ike Key. We have the traffic which is used to exchange the security association, and as we said, security association is one way. So we need different security associations in each way. So this is for key exchange. However, we have another traffic, okay, for control. Why بقى? Because we said that if we find that someone is sending to us packets which are before the window or outside the window, this is an alert for something, right? So, and you possibly need to reset the security association for the same tunnel. For the same tunnel, you need to do some renewal of the security association, right? So you need some kind of control messages that says, okay, so this is to notify you that there is a breach of the traffic in this IPsec tunnel. So you need to renew the security association. So this traffic is actually also initialized, and you need, in fact, another security association for the control traffic. So then you need security association for the key exchange. So you need to do a key exchange in order to establish a security association for the tunnel itself. Okay. So for the tunnel, you need security association. You need one on each way, right? But you also need to have a control traffic, okay, and you need another security association for that to be able to send some control messages to possibly alert that there is some kind of replay attack, or to send different configurations, or to renew the security association, and so on. So if you go back and look at the key exchange in high level, you see that you have this is to establish the main security association for both directions, اللي هو for the tunnel itself. ماشي. And this is to establish the security association for the control traffic, which is used again to send we see here this is بقى this is itself the control traffic. So first you need to establish the security association for the control traffic, and this is the control traffic itself. In the control traffic you see that you send NDCP, and this N is notify, delete معناها delete the entire tunnel, or configuration معناها change the configuration اللي هي could possibly mean change the security association or renew the security association and so on. Okay, so this is like a control traffic which goes in parallel to the data traffic of the tunnel. Okay, يبقى احنا عندنا two different security associations we have to do, one for the data tunnel and one for the control traffic, right? So this is required to establish the security association for the data tunnel, and this is required to establish the security association for the control traffic. And this is in fact the control traffic. The data traffic is not part of this picture. Data traffic is supposed to be here اللي هو actual data traffic, which is part of Ipsec بقى اللي هو ESP و AH والكلام اللي احنا اتكلمنا عليه. واضح كده؟ طيب, so to go back, we have initiator and we have responder. This could be two hosts or two routers, okay? Whether we talk about tunnel mode, transport mode, whatever. ماشي? It starts from the initiator sending a simple Ike traffic, which contains the SAI1. SAI1, if you look here, SAI1, it's actually the Diffie-Hellman group. So we are negotiating first that we need to. Diffie-Hellman group refers to like a stack of mechanisms. It's like this is the security level that I want to establish. Do you have this? So for example, you are sending to the other end saying, okay, I want to use a security level 1. Are you capable of using security level 1? He would say, okay, so yes, I have security level. Or I want to use 2. He would say, no, I don't have 2, I have only 1, and so on. So we have to negotiate the security level, which is referred to by the Diffie-Hellman group. Okay? So we have to send the Diffie-Hellman group, and then the KEI اللي هي ايه؟ KEI اللي هي Diffie-Hellman public key اللي هي الفاليوز بتاعت Diffie-Hellman اللي هي الالفا and Q and okay, so these وقلنا الالفا and Q, they are to be exchanged عادي, these are public to be exchanged. So based on this, طبعا the initiator will send this request to the responder. Responder always sends back, say, okay, yes, I can use Diffie-Hellman group 1, ماشي, and these are the public values, there's no problem, but you need to authenticate yourself. So I need to send certificate request. Certificate request, you need to perform authentication. ماشي? So by sending the Diffie-Hellman group on the public values and the public values, we can calculate shared key at this point because we have the public values for the Diffie-Hellman group. So we can establish on both sides, we can establish a shared key. ماشي? Again, this shared key is not part of the security association. This shared key is only for Ike message exchange only. Okay, so here we have a shared key. Now, from this point on, you see that this message is in fact encrypted with the shared key. The header, by the way, the header بقى contains اللي هو الكوكيز والاشياء اللي هي خاصه بالايه؟ بالميكانيزم. ماشي؟ to mitigate اللي هو denial of service attack and so on. Okay, and then from then on, I have the shared key, so I can encrypt all the upcoming values with this shared key. So the upcoming messages, they contain fields which can be categorized in two يعني categories. ID اللي هو ال IP address for the initiator, the IP address for the responder, and the certificate for the initiator. Okay, so it's like I'm saying, okay, so I'm now establishing a security association اللي هي ال SAI2. So SAI1 اللي هو security level. SAI2 بقى اللي هو actual security association for the data tunnel. ماشي؟ So this is the security association for the data tunnel, and I'm encrypting everything using the shared key that we agreed on, and I'm sending my certificate to authenticate myself. ماشي كده؟ So this is the most important thing بقى اللي احنا ايه. This is the security association that we need to establish, right? So this security association contains all the algorithms, the parameters that are needed for this data tunnel اللي هي including بقى ايه what is the encryption method, what is the authentication method for the data tunnel, message authentication codes, IV, pseudo-random function which can be used to generate the keys from the master key, or everything. So this is contained here.
But without keys.
The master, again, the master key is generated locally at each site, but I'm sending the parameters that you need in order to generate that master key. Based على ايه؟ Based على hashed values from all these values, and these values are all encrypted. So the IDI اللي هو ال IP address بتاع ال sender, IDR اللي هو ال IP address بتاع ال receiver. كل ال parameters دي they will be hashed using the pseudo-random function, and the pseudo-random function will use all these values to generate master key, right? From the master key we generate group of keys for بقى encryption for كذا زي ما عملنا بالظبط, similar, exactly similar. But here I put all the parameters that you need to generate that master key. تمام كده؟ تمام. For this is the most important part بقى اللي هو ايه? What are the parameters and the algorithms that you will use for encryption, for authentication, and so on. ماشي? And we'll see all these parameters in the next slide. So here I'm sending my certificate to authenticate myself, and I'm sending certificate request to request you to also both sides. ما انت مش, you are requesting that I have to authenticate myself. So you have to do the same, right? So here we see the certificate, and again we see the IP address, and we see all these parameters. And again you have SAR2 and SAI2. Why? Because we said that security association is one-way logical security settings, right?
That's why the certificate says two certificates.
No. Here I'm authenticating myself so that you know that the parameters I'm sending you as part of the security association is coming from an authorized person. This is to authenticate myself during the Ike Key Exchange, right? These are the security association that will be used for the tunnel, for the data tunnel. ماشي? So there's a difference here. ماشي? طيب. Here I'm doing the exact same steps using the same shared key, but for ايه بقى؟ For the control traffic, not for the data tunnel. ماشي? So here I'm again exchanging برضو security association here and security association here for the control traffic. ماشي? Once we establish the security association for the control traffic, the security association for the data tunnel, now we are ready to go. So the control traffic is here. The data traffic is not in this picture, but the data traffic is based on ESP and AH and all the things that we talked about before. ماشي? So now we have the data tunnel, we have the control traffic, so everything is set up. Okay, so we are ready to go. So this is the Ike Key Exchange. So by doing this, by exchanging this security association parameters, we can calculate, as we said, اللي هو master key locally بقى. ماشي? Locally based على pseudo random function. ماشي? And then from the master key we can generate all the other keys as we have talked about before. So we will end up doing or calculating the keys using all these techniques. So basically this refers to the Diffie-Hellman group. The Diffie-Hellman group refers to two stacks of techniques, okay, which correspond to two different security levels. The one here at the top is the virtual private networks, which is part of RFC, this 4000, you don't have to memorize it, obviously. This is for all the world except the US. The US uses the part at the bottom here. US always tries to be طبعا special, unique طبعا. فطبعا you see here ليه بقى؟ Because the standard for the US includes two different stacks. Each stack is two different levels. This is for the classified information عشان المخابرات وكده يعني. So that's why you see هنا null لأن هي أصلا already هي classified already. You don't have to do anything. Information is already classified. And this is for the unclassified. ماشي؟ يعني we don't have to really يعني memorize this طبعا in any way. But what we need to really understand is that you notice that let's talk about the يعني other parts of the world other than the US. You notice here that this stack is less secure compared to this. حتى given the techniques that we have studied before, we can really recognize easily that this stack is more secure. Why? You see here triple DES versus here AES with cipher block chaining, right? So AES with cipher block chaining can really be a much more secure with less complexity كمان. تمام؟ and here طبعا the Diffie-Hellman group here, the Diffie-Hellman group here is 1024 بينما here is 2048. Obviously double. So obviously the security level here is much more compared to here. واضح. ماشي كده؟ And all other techniques بقى you see all other techniques they are more secure here compared to here. طبعا you have هنا the pseudo-random function, and this is very key. Pseudo-random function is what we use again to hash from these values and create the master key and later on all the session keys and temporary keys and so on. So the pseudo-random function is also can use different mechanisms here. ماشي? So that's in a nutshell the Ike Key and how it's used. Based on this message exchange, again, we create the data tunnel, the Ipsec data tunnel security association, which is one security association for each direction, and also the security association for the control traffic, okay, which is used to send some alerts regarding any kind of breach to that tunnel. Based on that, we can renew the security association and so on. And for both the control traffic and the data traffic, we need these mechanisms as part of the security association. Okay.
So do we need something like this for the homework, like a stack?
For the homework? No, for the homework, يعني you don't need to be that complicated. What you need to do for the homework is only for encryption and for message authentication. That's it. ماشي؟
Not even a key exchange.
لا, you don't have to do key exchange. You can set the key. يعني you can يعني use a predefined key. Just make it simple. You don't have to do back key exchange والكلام ده. It's not part of the requirement. The requirement says that you have to implement the main pillars. لما confidentiality integrity and non-repudiation. Integrity and non-repudiation are fulfilled using the message authentication codes, right? So you don't have to make it complex, يعني more than what it really is. ماشي. Any questions? So this is the end of this chapter really. In Ipsec, طبعا, this is considered to be the most complex chapter really because of the nature of Ipsec that it needs to secure tons of traffic, يعني different types of traffic coming from different hosts, and you can secure on different levels, whether network to network or host to host. Whether network to network or host to host, we're talking about a group of traffic that needs to be secure. So therefore, we need to have security policy database. We didn't have to, and as we see in the next chapter, we don't have to talk about this for the next chapter as well for TLS. For also another factor that affected really the complexity of Ipsec is the characteristics of IP being connectionless and unreliable. ماشي? Having IP connectionless and unreliable also creates some kind of complexity because you have to create security association as one-way logical security settings, and also you have to address the replay attack using anti-replay window and all of this complexity which we did not have to deal with in other layers. Okay? طيب. So this is basically in a nutshell the summary of this chapter. We talked about these different parts. Now we need to jump to chapter 6 where we talk about transport layer security. طبعا just to be on the same page and to really visualize the context here, that here we're talking about a one host here, and one host as a sender and one host as a receiver. ماشي. Each host runs multiple application endpoints. صح كده؟ And here you have application endpoints. ماشي. And now we have TLS. TLS, by the way, always runs on top of TCP. Because there is a DTLS, which is a datagram TLS, okay, which runs over UDP. And in that case, we will not study it here. But again, in that case, you can imagine that again, DTLS is affected by the fact that UDP is connectionless, is unreliable. So you will see the same level of complexity like Ipsec pretty much. But luckily here we have TCP, and TCP is connection oriented, and it performs application endpoint connection, which is by default bidirection, and we need to establish the security between two application endpoints, not host to host, not network to network. ماشي? So you will see the security header comes after the TCP header. ماشي? After the TCP header. And it's valid in the context of application to application endpoint فقط. ماشي؟ طيب. TLS, of course, was originally designed to secure World Wide Web, to secure web services. ماشي? Later on, it has found its way to secure other applications like email and other things. But originally, they designed it for web services. Particularly, this is motivated by the fact that the web services are really طبعا widely available, وكمان الweb services are mostly text-based. Text-based makes it really exposed to different types of attacks. يعني انت if you browse any web page, you can say view source, and you can see everything, including حتى the JavaScript, including everything. And this creates a big attack surface, okay, for different attackers to really find some loopholes to use it for attack. That's why the TLS was designed to originally replace SSL. SSL was the secure socket layer, was an incremental standards to HTTP to try to secure web services, right? So TLS was designed originally to replace completely SSL. حتى TLS version 1 اللي هو 1.0 was not even backward compatible. They say that, okay, so we will standardize TLS 1.0 and we will ask everyone to replace TLS with SSL. Okay, so anyone that uses SSL, they need to use TLS. طبعا later on they found that this is not possible. This is a mistake, really. So standard developers, they do mistakes. They are not perfect people. They do mistakes. And this is one clear example for mistakes that can be done by standard developers. So later on, they came up with TLS version 1.1, which is backward compatible with SSL, to try to motivate people and encourage people to use it in replacement of SSL, which means that when many browsers now, if you do HTTPS, chances are the browser uses TLS, not SSL. ماشي? And it's backward compatible. Okay. Type. So again, similar to the fact that we have been affected by the characteristics of IP in the network layer, here again we are affected by the characteristics of the World Wide Web, which is the main purpose of designing TLS, right? So web servers are relatively easy to configure and manage. As we said, everything is text-based, it's easy to use, but of course, in order to make it very easy for the users, it's very complex underneath. So the web servers themselves, in terms of underlying complexity, is really high. Web servers themselves are really high in terms of complexity. ماشي. And this is to be able to deal with lots of content on the World Wide Web. The underlying software is extraordinarily complex, okay? In order to make the front end for the users very easy to use. It's similar عارف للكونسبت بتاع ايه برضه الكونسبت بتاع الجافا برضه is ايه we need to make the Java very easy and unified across different platforms. So the Java JVM has made very, very complex in order to make Java really usable on all platforms and stuff like that. Okay? So the easier it is for the user, the more complex it is underneath. ماشي؟ طيب. So this may in fact hide many potential security flaws that can really be used and utilized by attackers. Okay? So in that case, the web server can be exploited as a launchpad that now attackers, they can gain some control to some web servers or web clients and they can use it to launch an attack, distributed attack. مثلا زي اللي هو distributed denial of service attack مثلا. So this is the danger of controlling a distributed system like this. Okay? So also there is another characteristic which is very important. The World Wide Web and web services can be used by untrained users. So no matter what you do, تلاقي user, he clicks on any link that he sees and this link is phishing and they can really trigger requests to illegitimate web servers. They can really be part of a big attack and they can cause certain damage. So such users are not necessarily aware of security risks that can be caused by their actions. ماشي? So by clicking certain مثلا link, you can get to a fictitious web page that you don't recognize that this is really part of a illegitimate web server. So you start to deal with it as if it's a legitimate web server. And it gets all your information, credit card information. It asks you to buy certain stuff. And أنا نفسي حصلت لي قبل كده يعني والله. فيعني really يعني if it happens to someone like me, so imagine بقى untrained users who do not know يعني anything about these security issues, they can really fall in such traps very easily. So all these characteristics constitute now the challenge that we are facing. So we need to really design TLS to really secure client to server interaction. Here, we're not talking about host to host, network to network. Here, we're talking about TCP session, and we know, I shouldn't say session, TCP connection. ماشي? So now we need to design a security protocol which can be used to secure the application to application traffic. So here we're not talking about anything new. Here we're talking about the different threats and the countermeasures. Nothing is new here, except that we have some added information related to the fact that here we're talking about web server and web client. So here when it comes to integrity, we know what integrity is, but here because of the fact that the web services, they are text-based mainly, ماشي? And lots of code is text-based, even JavaScript is viewable. So now we can introduce some Trojans. Again, Trojans are part of integrity or active attacks. You can change the JavaScript itself to allow the user to get into a different link, different website, and hence you can leak some information. So this is some kind of integrity attacks. Confidentiality, so eavesdropping, you can you can read some traffic between two end applications. You can sniff or you can read some مثلا credit card information, things like that. So denial of service, this is by default, this is by far the most difficult, always. Denial of service attack is by far the most difficult thing to really mitigate because I mean, even if you can detect that this is a illegitimate request, even if you can detect it, okay? But in order for you to detect it, you have to spend some time. So imagine if I'm sending you millions of illegitimate requests. big overhead. So a web server is really intelligent, and it can detect that this is a legitimate request and this is a illegitimate request. Fine, but in order to detect that this is a legitimate request, it has to spend some time, and the complexity is high, and therefore it can actually go into a denial of service state, okay, and it can perform, or it can go through delays to really process the legitimate requests. So, so flooding machines with bogus requests. So, as we said before, if we are receiving millions of requests from the same IP address or the same port, that's easy. But the problem is that denial of service is always actually performed in a distributed way. So they call it distributed denial of service. This is the most difficult because the requests are coming from millions of IP addresses, okay? And again, this requires the fact that you have to perform some active attack to gain control to all these machines. That's why I always advise my kids, do not leave your laptop open overnight. Because what happens is that these attackers, they run these crawlers and then they try to scan, they do port scanning for your laptops. If they see any port that's open, they get into the machine from that port and they perform some active attacks. They gain control. Then from your machine, they can perform distributed denial of service. Some people, they use your laptops for mining on blockchain. They can use it for all sorts of things. These attackers are very smart. Actually, we have two of the laptops at home. They actually have hardware error because of the fact that overnight they are being used for very, very highly complex operations that even the fans, they are not able to cool down, and they burn the motherboard. I have especially the اللي هي الحاجات very thin اللي هي زي التابلتس. These are very easy to get really heated up وكذا. So these denial of service attacks are very, very easy are very, very hard to mitigate.
How do they decide I'm going to crawl into this port because this device is connected to a certain site, or?
No. Yes. They try to send requests. There is software that can do port scanning. Right, port scanning, it tries to send some request. I need to connect to you on this port.
Within a certain range, or just?
Yeah, scan all the ports. عندك يعني البورت 65,000 ports.
Right.
خلاص, scan all the ports. It takes seconds to scan all the ports to find. طبعا, of course, you have to do port scanning for a certain service. So you can do مثلا HTTP request on port كذا مثلا, أو any TCP connection on port كذا, any port, and you try to see which ports that are open. From that port, you can get into the machine in a certain way, and you can just insert some Trojans. These Trojans, these are not to really damage your مثلا file system.
Background.
No, just a process that they can put on your machine that they can use it as a client to connect to anything. As I said, whether to use it as for mining, whether to use it for distributed denial of service attacks, whatever. Okay. طيب, and of course, authentication here, which talks about impersonation, because if I do man-in-the-middle attack, and I can really مثلا authenticate myself, or I can send a request as if I'm a different person, then we need some kind of authentication mechanism to authenticate the user and authenticate every single message to make sure that it's coming from a legitimate user. So the important thing, طبعا, of course, this one we talked about. We talked about IP and IPsec. Okay. So IPsec here talks about the fact that IPsec is always implemented as part of the operating system kernel. Okay. So when you use VPN and stuff like that, it's agnostic to whatever application you are using. So that tunnel is going to be shared by everything, by all the services, all the application services, and all the traffic that is coming from this host, right? Of course, according to certain policies, some traffic may be bypassed, as we said, right? But this IPsec is application agnostic. It's by default shared to all the applications. When it comes to طبعا of course Kerberos, we talked about Kerberos. Kerberos is for application level security. So Kerberos affects one certain application only, one certain service only, right? Well, the idea about is that TLS and SSL, as we said, TLS is on top of TCP, okay? And this is for application level security. The trick or the idea about of transport level security, it can be implemented as part of the operating system and used by any application. Okay? So it can be built as part of مثلا Windows or Apple OS. Okay? And then it's an option for securing any application. So for example, in email, we say use TLS. So when we use TLS, we secure the email application.
System call.
Yes, so it's a system call, exactly. So we use TLS as an option. Or TLS can be used only within a specific application. Like the browser itself implements TLS, not in the kernel of the operating system. The browser itself implements TLS, and then by default it uses TLS as part of the browser itself, the application. So there is two different ways of implementing transport level security, whether at the operating system kernel, in which case it's valid as an option for any application, or it's built within the application itself, like it's implemented in the browser. ماشي? So one of the most widely used احنا بس مش عايزين اوكي طيب احنا طبعا we have wasted some time to اوكي خلاص